Welcome everyone to the October 2024 Freshwater Quality Research Programme webinar. I'm Joseph Holden from the University of Leeds, and along with Pippa Chapman, we both sort of champion the UK Freshwater Quality Research Programme as a whole. And the programme is looking to really try to ultimately improve freshwater quality, and do that through improving our understanding of the sources and behavior of pollutants, increase our knowledge about how pollutants are changing and how they're interacting with the environment, and really look at how we then, this information, this scientific information, can inform policy and generate improvements to the ecological status to rivers. So that's the kind of, the overarching objectives. And the program is made up of 5 pretty large projects, each with a whole group of collaborating organizations working together. So we have the projects on screen: Quantum Pacific, LTL, SFE, MOT for Rivers, and EcoMix, and they're all looking at different angles around freshwater quality in the UK and working together on different elements across the program as well. So if you want to get updates on each of those individual projects, you can look back through the videos, the recordings of some webinars from the program, but we also intend in early 2025 to have a sequence of webinars which will update us on progress on those projects by different staff members within the projects themselves. So do make sure that you and your colleagues are sort of signed up to our newsletter. There's a QR code there with various links and so on, to signed up so that you get access to the kind of webinar information. But just as a reminder, one of the benefits of joining live, so for those who are watching the recording of this, the benefit of joining live is that you can interact during the webinar. So at the end of the webinar, each webinar, we then have an open Q&A session with dialogue and discussion and so on. And so you get to ask questions. We'll open the microphone for those who where we think there's an interesting discussion happening, and you get to kind of interact. So I encourage those who are just watching a recording of the webinar to then, join us live for future events. And so there's a couple of upcoming webinars. On the 12th of November, we have one on biosecurity and invasive non-native species, which will be delivered by Professor Alison Dunn from the University of Leeds. And then December, we'll confirm that date in the next few days. There'll be one on a modelling framework, which has been developed at Imperial College London by Barney Dobson. So we'll look forward to those upcoming webinars. So that's just by way of introduction. And now I'm really delighted to hand you over to Dr. Matt Hill, who's based at Yorkshire Water. And he's going to tell us about the UKWIR's Chemicals Investigation Programme, which has actually been running for quite some time and received a lot of investment from the water industry. And so it's fantastic that Matt's given us some time today to tell us about the programme and give us an update on what it's been doing and what the findings are. So Matt, over to you.
Thanks very much, Joe. I'm just going to try and share my screen. How's that come up?
That's perfect.
Great. Well, good morning, everyone. Thank you for inviting me to speak. Today, I'm going to give you my perspective briefly on when chemicals in the environment are a problem. Then the real meat of the talk is about what the Chemical Investigations Programme tells us about chemicals and the water industry. And finally, a little think about what that Chemical Investigations Programme will do from 2025, which is our next 5-year programme. So the question is, which chemicals? Chemicals, any substance with a defined composition. Those that cause concern are the ones that I've listed on here, and the presentation should be available with links to all of these after the talk. So they are priority substances and priority hazardous substances, specific pollutants, operational pollutants, and other pollutants. These have been defined by the Priority Substances Directive, the Water Framework Directive, the Environmental Quality Standards Directive, and the Environment Agency. So these are separate from the sanitary determinants traditionally used to manage wastewater impacts in the environment, such as biochemical oxygen demand, ammonia, and suspended solids. So in this talk, I'm going to call all these non-sanitary chemicals that can cause harm hazardous substances. And some common groups of hazardous substances are things like pesticides, like metaldehyde, cypermethrin, and acetamiprid. This is a neonicotinoid in these garden centre products. Flame retardants, particularly the per and polyfluorinated alkyl substances, or PFAS, or forever chemicals. Over-the-counter pharmaceuticals like ibuprofen and paracetamol, and also prescription pharmaceuticals including fluoxetine, the active ingredient in Prozac. So when these are a problem, as a result of our consumption of these chemicals, there are thousands of hazardous substances in the environment. The forever chemicals, or the PFAS, are just one group, and the Environmental Protection Agency Toxicity Database currently lists 14,735 unique PFAS chemical compounds. Now, because of advances in analytical science, these hazardous substances are being detected more often throughout the environment, including in fish and shellfish and in us. Environmental regulators in the United Kingdom use environmental quality standards, or EQSs, to determine when the concentrations of 148 selected hazardous substances in rivers and coastal waters are too high. As these EQSs are derived from ecological studies on relevant organisms. So according to the regulators, hazardous substances are a problem when they exceed the EQSs, either an annual average for chronic effects or a 95th percentile or maximum allowable concentration for acute impacts, such as this fish kill. These standards are for single hazardous substances, no antagonistic or synergistic impacts of multiple pollutants are taken account of. So the environmental regulators regularly compare concentrations of hazardous substances in rivers against their EQSs. If just one of the 148 is exceeded, then the water body is considered to have failed. This slide shows the Environmental Audit Committee report from a couple of years ago for English water bodies. Under water quality, we see varying amounts of water bodies at good status for different indicators of biology, water quality, and physical modification. Generally okay, but with work to do. What appears to be the big problem is that none of the water bodies in England were good quality because in each one, at least one hazardous substance exceeded its EQS. This has led to multiple headlines stating that no English rivers are good quality. Just to underline it, this is a map that's available on the River Basin Management website. Every monitored still water and every river has failed its chemical status. So the Chemical Investigations Programme is the UK water industry's response to these concerns about hazardous substances in the water environment. It brings together 10 water and sewage companies in England and Wales with Defra, the Environment Agency, Natural England, Natural Resources Wales and Ofwat to investigate the range of hazardous substances often contained in many domestic products that find their way into sewage and biosolids and reach rivers and streams. We're also investigating who or what is responsible for them getting there in the first place and what can be done, if necessary, to reduce concentration. The programme focuses on our wastewater treatment works, hence the lovely aerial shot of Keighley Marley sewage treatment works. Many of these chemicals, including metals, fire retardants and biocides, have the potential to be present in both untreated sewage and treated effluent. So to help address this challenge, the water and sewage companies funded work in 3 asset management periods over £25 million in 2010 to 2015, 140 million 5 years later, and 25 million in this current asset management period leading up to 2025. I'm going to try and give you the clear messages that came from our work in each of these phases. The Chemical Investigations Programme Phase 1 launched in 2010 And that was 6 years before England and Wales's freshwater quality monitoring programme included extra chemicals for the first time, such as cypermethrin, diazinon, perfluorooctanoic acid, and perfluorooctane sulfonic acid, PFOA and PFOS. Sorry. Phase 1 was split into 3 key projects, addressing the questions we had at the time. C1 looked at what chemicals are being discharged into the environment in final effluents. C2 looked at what impact wastewater treatment has on the chemicals in the influent, and where do the chemicals in raw sewage come from, was the third different project. So 162 wastewater treatment works were sampled for these effluent surveys for up to 47 hazardous substances over 14 months. This produced about 3,000 results for each hazardous substance, with the limit of detection being exceeded most of the time for the 26 substances. So this means it's possible to detect nearly all contaminants in nearly all effluents. We're looking at a lot of chemicals in there. The swans potentially enjoying the relatively warm final effluent from Stoke Bardolph wastewater treatment works being discharged into the River Trent in winter here are also being exposed to a wide range of chemicals. In phase 2, we tried to see what impact wastewater treatment has on chemicals in the influent. 28 wastewater treatment works were sampled before and after primary, secondary, and tertiary treatment. These represented 2 treatment work types: activated sludge plants and biofilters. Overall, about 3,500 samples were taken, giving about 250,000 different determinations. So the pharmaceuticals in this chart of median removal rates showed the greatest variability of different groups of chemicals. The non-steroidal anti-inflammatory drug ibuprofen and the antibiotic oxytetracycline show good removal rates. The prescription painkiller diclofenac and the beta blocker propranolol less so. In summary, treatment rates for wastewater treatment works vary for different hazardous substances. Some are hardly removed at all, and some are almost totally removed from the sewage. And in the third phase, we wanted to find out where these chemicals that we found in our effluent and raw sewage were coming from. So 9 moderately sized urban catchments with population equivalents between 55,000 and 200,000 were selected to represent the type of catchments that most people live in. These were sampled upstream of the wastewater treatment works at discharge locations with domestic foul sewage, domestic grey sewage, trade effluent, town centre discharges, light industrial discharges, and surface runoff. Apart from some metals, we found that the great majority of substances are of predominantly domestic origin. There's a link between the products that we buy from those shelves in the garden centres that we saw and our sinks, our washing machines, and our toilets that impact upon the environment. So that first go, the CIP phase 1, gave us the steering group the confidence to design further research from 2015 that hoped to address the questions that had arisen. So phase 2, after we found out that the chemicals were present, the question was, do these hazardous substances threaten river health across England and Wales? And could we trial different types of tertiary treatment to try and remove hazardous pollutants better from wastewater? And also, we wanted to see whether catchment scale improvements could be made for chemicals of concern. And our final project in SIP2 was looking at how much phosphorus can be removed from final effluent by tertiary treatment. So in terms of do hazardous substances threaten river health? We targeted those wastewater treatment works that were most likely to pose a threat. The steering group selected 600 or so of the largest wastewater treatment works with the least dilution in the receiving watercourse. It's important to recognise this wasn't a representative sample of the 700 or so wastewater treatment works in England and Wales. The investigation took 20 final effluent samples and 36 watercourse samples upstream and downstream of each works, spread over a year and 18 months respectively. 48 different hazardous substances were analysed for. What we found was that fewer than 10% of the watercourse samples exceeded environmental quality standards, apart from some specific chemicals. Benzoylpyrene, PFOA, fluoranthene, PFOS, and HBCDD, the hexabromоcyclododecane. These are all ubiquitous, persistent, bioaccumulative, and toxic substances as defined by the Priority Substances Directive. But there are also a couple of interesting ones. Soluble reactive phosphorus and cypermethrin seem to show impact in the watercourses, according to our outputs here. The next project we looked at was how well the different types of tertiary treatment remove hazardous pollutants from wastewater. So we used 15 different tertiary treatment technologies in 31 different trial configurations, including shown here coagulation with pile cloth filters, Blue Pro reactive filtration system, the nitrifying submerged and aerated filter and tertiary nitrifying filter shown on the right. They're all monitored to see how they removed up to 74 different hazardous substances. Unfortunately, no one technology effectively removed all the substances. But the investigation allowed the creation of a site-specific options appraisal cost modelling tool. And this tool has enabled water companies to more accurately estimate treatment costs where river needs limits are proposed by the environmental regulator during creation of the Water Industry National Environment Programme every 5 years, or the YNEP. In terms of the catchment, we looked at 5 river catchments, the River Alt, Arun, Erewash, Ouzel and Natim, where discharges to watercourse and sewer were monitored for substances including tributyl tin, triclosan, dissolved zinc and mercury, cypermethrin, HBCDD, PFOS, PFOA, bromodiphenyl ether 47, and the polycyclic aromatic hydrocarbons, benzoylpyrene and fluoranthene. So the ubiquitous persistent bioaccumulative and toxic substance benzoylpyrene was found at concentrations greater than 100% of the environmental quality standard in the discharges to all catchments. So the presence is there from a lot of different sources, but each catchment had its own unique chemical signature. Industrial estates and surface water runoff showed the highest concentrations of tributyl tin and hexabromоcyclododecane, with intermittent discharges such as CSOs, combined sewer overflows, important sources of benzoylpyrene and fluoranthene. Our final part of SIP2 was going back to these technology trials to see how much phosphorus could be removed. 11 of the 15 tertiary treatment technologies used to address hazardous substances removal were also checked for phosphorus removal. The processes were optimized for phosphorus removal, and we found that the technically achievable limit, which was what the Environment Agency was looking for in terms of phosphorus regulation, was only down to about 0.25 milligrams per litre of total phosphorus. So that helped the agency in their subsequent regulation setting for this pollutant. So in terms of the chemical investigation program phase 3, SIP2 was a huge undertaking by the water industry. It pushed the capacity of the country's sampling and analytical services to the limit and delivered vital information on the concentration of hazardous pollutants in water courses and the extent to which they and phosphorus could be treated at wastewater treatment works. Now, SIP3 was a reduced program in terms of expenditure, but it was more diverse, including several aspects of hazardous substances at wastewater treatment works for the first time. And most of the work was delivered in the first 2 years of the asset management period 7, so that conclusions informed the price review for the next asset management period. So there are 4 key aspects here. They're not all aspects of SIP3, but I want to talk about these 4. Having run the SIP for over a decade, we were able to use previous results with targeted monitoring in AMP7 to investigate the die-away in the environment of hazardous substances. Also, whilst we had learnt a lot about removal of hazardous substances from the final effluent, we understood much less about the biosolids we mainly spread to agricultural land and the substances within them. The O'Neill review had been published into antibiotic resistance in May 2016, and despite the key findings not including this recommendation, the steering group decided to investigate how wastewater treatment works impacted upon antimicrobial resistance. And throughout this period, increased media attention on microplastics has led to the steering group deciding to investigate the performance of wastewater treatment works in removing those microplastics from sewage. So the concentration of 20 selected determinants in final treated effluents was compared to previous CIP data and data collected from 50 wastewater treatment works during CIP3. Mean data were modelled to estimate mean concentrations in 2027, when the current Water Framework Directive River Basin Management Plan cycle ends. SIP3 data have shown mostly downward trends, but benzoate and mercury, both UPBTs, showed an upward trend over time. Of those determinants with downward trends, the most striking indicators over time were triclosan and tributyl tin. These substances are subject to bans in the UK, and they dropped from final effluent concentrations above their EQS in 2013 to below that EQS by 2020. In terms of the investigation of chemicals in biosolids, samples were taken in many of the investigations in SIP3. The biosolids report used the results from these samples to give an overview of hazardous substances in biosolids. In common with the earlier CIP catchment studies, a unique chemical signature was found in each catchment. This chemical diversity for final effluent was further influenced by the input of tankered trade waste sludges to wastewater treatment works. It is possible to deduce, with substances including microplastics and antimicrobial resistance, which substances, are likely to be introduced to the environment through the land spreading of biosolids. But an assessment of the environmental risks associated with the levels observed in this study was outside the scope of this report. We also looked at changes to antimicrobial resistance through wastewater and sludge treatment. 10 different wastewater treatment works were sampled 6 times over the course of 11 months, representing a range of secondary treatment processes. They're effective at reducing the abundance, that is gene copies per litre, of antibiotic resistant genes, ARGs, in the final effluent, with 97% of the influent to effluent pairs examined having a negative log-fold reduction. The percent removals ranged from 83% to 98% for different antimicrobial resistant genes. There was no clear trend by treatment type. Ultraviolet tertiary treatment had no measurable impact on AMR in final effluent. Other primarily biologically based tertiary treatment units were generally effective at reducing the abundance, the prevalence, that's genes per cell, and the richness, numbers of types of genes, of antimicrobial resistant genes in effluent. It was not possible to identify correlations between antibiotics or metals and measures of AMR, indicating that other processes may be more important in determining antimicrobial resistance in wastewater and sewage sludge. There was an investigation into the fate and behaviour of microplastics. So 10 relatively large wastewater treatment works representing a range of secondary treatment processes were visited 4 times, once each in spring, summer, autumn and winter. Microplastics were captured from different points in the treatment process and processed and analysed by microfourier transform infrared and interpreted with simple software. High removals from the final effluent of 99% by number and 99.5% by mass of microplastics were observed across all the wastewater treatment works. The most common polymer type found in the microplastics was amorphous acrylate, followed by polyethylene and polypropylene polymers. The fiber forms and polymers associated with textiles were insignificant in terms of number and mass in the samples, despite shedding from clothes being identified as a significant source. Overall, the primary and secondary settlement stages were particularly important with respects to the proportions removed. All polymer types appeared to be removed to the same extent, leaving on average 1 microplastic particle per litre in effluent. If these results are representative, then discharge to rivers of microplastics by number and mass are very modest. However, due to the effective capture in sewage sludge, the export of microplastics from biosolids to land could be significant. So that's what's happened so far the last 15 years in the chemicals investigations program. We continue to invest and research in treatment. In AMP8, that is 2025 to 2030, we'll be spending around £50 million on chemicals investigation program phase 4. We'll be looking at PFOS in sewer networks. Although it is a ubiquitous chemical, the regulators feel that there may be particular traders where there are significant discharges into our sewer networks. We'll be moving from the impact in the final effluent on watercourses to focus a bit more on the impact of biosolids spreading on soils and groundwater. And we'll also be looking at substances of emerging concern, substances which are being identified as being fresh concerns by the Environment Agency. But we'll also be continuing our research into microplastics and antimicrobial resistance. And we're not keeping all these results for ourselves. All of the CIP data and reports are available for free on the UK Water Industry Research website. There are instructions there to go to the tools where the raw data for all the chemicals investigations is available. You can access millions of data points from all the phases of the CIP. There are also reports and further data annexes available via the publications section of the UKWIR website. So it might be actually feeling a bit down that we found so many chemicals in so many places, but there is an upside to this. River quality is getting better, according to Professor Andrew Johnson's analysis of macroinvertebrate communities in the UK. Because of investment in treatment over the last 30 years and under greater scrutiny and pressure from all those who enjoy our rivers, it seems the quality as measured by benthic macroinvertebrates is improving. So in summary, I hope it hasn't been too much of a whistle-stop tour through the chemical investigations program, and it will spark some conversation to come. Overall, there are several environmental quality standards that are being failed for chemicals in watercourses, but these are generally from ubiquitous, persistent, bioaccumulative and toxic substances, UPBTs. Chemical removal at wastewater treatment works is uncertain. Many failures are upstream of wastewater treatment works, so from sources that are potentially not from wastewater treatment. A lot of chemicals come from domestic customers. So in terms of the water industry managing it through trade agreements, trade waste agreements, it's more challenging. Positives are that the bans have led to the decline of some chemicals in the environment already. Caution has to be exercised in the fact that chemicals, although removed from final effluent, are just moved into the sludge, mainly not destroyed. And that includes microplastics and antimicrobial resistance. But we continue with Chemical Investigations Programme 4, and there's already been some discussion about another phase in 2030 to 2035. So that's everything really that I wanted to say. I hope it has been an enlightening talk for you.